So here we go, scientists. I am so lucky I'm keeping the same journal during this time because I did not lose my recording of our experiment and our hypothesis. Surface area and evaporation hypothesis. A container with more surface area will lose more water in a week than a container with less surface area. Each one was filled with 1/2 of a cup, 1/2 of a cup, 1/2 of a cup. And what we actually found was that the container with the largest surface area ended up with the most water, followed by this one. We realized that that was due to the fact that the containers were kept outside in the rain. So what I did March 30th, scientifically, was I put the containers on this shelf, each filled once again with 1/2 cup of water, and I added a container. I added a Coke bottle container. And I did this so they'd be kept out of the rain, and I said I would check in a week. Now, I think you know today is April 27th, 2020, so I didn't check it in a week. I set the experiment up on the 30th of March, and it's now April 27th. So I left them untouched for 27 or 28 days. My initial hypothesis was containers will lose more water if they have a bigger or wider surface area than smaller surface area. So if my theory is correct, with our new experiment that we conducted or did, the container, this one, that has the smallest amount of surface area should have the most water left. Sorry about that, my phone cut off due to storage issues. So my hypothesis again was that the surface area that was wider would lose more water, and I was going to do it over a week. So now I want to be prepared to look at the results. So I set this up earlier with you all in my notebook. So far I only have this, but I need more, so I'm going to write more right now. All right, it's time to look at our data. I'm going to start with container C, which is our Coca-Cola bottle. I'm going to measure how much water or H2O is remaining in here with our new measuring cup and see what it tells me, what it tells us. So I'm going to kind of let it stabilize there and see if you can read what it says. So here's the 1/2 mark, and it's a little bit less than 1/2. I'm actually seeing a new measurement on the other side that I'm going to use for this one. So container C, today's results for container C, now 427, has what looks like maybe 1/4 of a cup. I'm not quite sure. I can tell you on the other side, it has 4 ounces. So on the other side of this measuring cup, there are OZ ounces. The OZ measures ounces. Ounces measures liquid. So there's 4 ounces for sure, and I need to go and see what that equals here. I'm writing my data down so I don't forget. That's container C. Now, I am going to pour it back using this cool device that Pat let us use. This is a funnel that is really cool, and it like tips out. I want to put all the water from here back into the original container. I know that some of the water just might, in general, through droplets, not go back in. So I'm going to let it sit for a while. Let's look at container B. Container B was this one. Let's find out how much H2O is in there. I am between containers going to dry out this one. I realize that means some of the water might have not gotten in here, but I want it to be as accurate as possible. I'm going to pour in. Let's see what container B shows us here. Try to get all the droplets in. Can you see that? That is way less. That's way less than the other one was, 1/2. I might even say that's 1/8 H2O left. That's what we expected. And let's look, let's see. Yeah, it looks to be 1/8. If I turn it to the other side, remember the other one was at 4 ounces? You can see how much less. That looks like 2 ounces to me. They don't even have a line for it, but it looks like it's about maybe 2 ounces. Way less in container B. Again, I'm going to pour it back into the same container. Again, realizing that a bit of the water will be lost through this, I have to put that into my data that some of the H2O is getting lost by drying. I am now prepared to look at container C. Container C, I expect to have the least amount of water. And let's find out what it has. Ready? Let me pour. No water. It's gone. The only thing you see in the bowl is this. What do you think that is? Now, if you guess that that's the watercolor dye, you're right. Remember, this one had watercolor dye on there. So we probably wouldn't even know there was water in this bowl except for the watercolor dye. It's completely gone. So now there's no water and it's dry. So if I think about the hypothesis that the container with the widest surface area, A, will have the least amount of water, I'm right. This was container A and it has none. Surface area B will have more left. Container C will have the most left. And we proved it to be true. Now, that confirms our data, but I'm hoping some of you can try a similar experiment at home. Think you can? Try it out. So scientists, the data confirm what I thought would happen. And I want to now think, what does this tell me? Well, there is still water in 2 of the 3 containers, so it didn't completely evaporate. The container that has this amount of surface area still has a bit to go, and this one has more time to go. So now with these results, I'm trying to come up with a new experiment, and I think I have one. So I thought a bit about the data that we got, and I came up with a new investigation. My new investigation says, how long will it take for containers B and C each to lose their remaining H2O? And then I thought about this. How can I use math to help me predict? I want to predict a date when they lose their H2O, each of them. And I want to think mathematically, going back to the data, how can I use math to help me? I'm not going to spill the beans on that. I want you to think. Maybe you have an idea for me, or you can come up with your own idea. Shall we? Scientists, what I've done is I've put the 2 containers back on the shelf. It's April 27th. I have it in my notebook. And I am not going to disturb them. I'm going to check on them more frequently, though, because I want to see if they're losing water so I can get the exact date. So now I have to check on them probably every couple days to see if they are losing water through evaporation, and what day they actually lose all of their water. That's about it for today's science. Hopefully you can come up with your own experiments to conduct, or you can try mine. I would love for you to try mine. That way we can compare our notes, and that is what scientists do. Be well, be safe, wash your hands. We love you. Bye.